Hi, my name is Vahan Davodian. I'm a physics experimentalist for 30 years. And then today's topic is going to be further analysis for wave-particle duality. First of all, I'd like to thank so many people. They emailed me, they had some comments, and that was so rewarding. And that's a good encouragement, and this is also the best feedback for me. And hopefully today, because quantum physics is conceptually not easy to understand or comprehend. So what I'm going to do today, just to slow down a little bit and then make sure I just be articulate and enunciate the word so everybody will understand, because it's a little bit complicated. We'll understand exactly what do we mean by quantum theory. So further analysis with for wave particle duality by Vahan Davodian, physics experimentalist, and this is my email, vahandavodian1948@gmail.com. This wave particle duality has been, concept, the main concept of the, debate for 1900, and so many physicists and, chemists, they just, had so many ideas, and finally Niels Bohr and Werner Heisenberg, and especially the most important one was Louis de Broglie, the French physicist. They came over, they solved this problem. So, charged particles like, light and electron can have both properties of wave and particle, but it depends on how you set up your experiment. This is so important that, even the single photon going through this, double slit will cause the diffraction. But why do we need to talk about, Thomas Young double slit? The reason why, this is the only experiment which happened to be the most important experiment, is explaining both, but I will explain when I get there, and then you can see why we choose that Thomas Young experiment. And this is so important that I found this in a physics book. That was old book, and then his name was Christian Huygens, one of the greatest Dutch physicist, and then he discovered the nature of light, and then the wavelength for the lights and everything else, and this experiment was there. And like I said, this was an old, very old book, but I'm glad I found this. So you can see his name was Thomas Young. He was a doctor, medical in London. That's why he started his double experiment. It'll be my next poster, and then I will explain with great precision. You can see why this experiment is so good and so important, and it tells you that the light is electromagnetic. So this is the one I chose from the Christian Huygens books, and you can see there's a light here, and they're shining through single slit. Then you can see here we have the diffraction. And in fact, I have to explain about the diffraction. Anytime you have a light go through any opening, it's called aperture, will diffract. So in other words, it's going to go around it. And then at the same time, Thomas Young discovered not only they will have diffraction, but also they have interference. So that's why he theorized that the light is electromagnetic. So you can see here the light shines through this single slit. So what happened, you see these lines, is all diffractions. At the same time, the same light continues to a double slit. This is the one Thomas Young did, and it shows over here when they overlap each other, what happened, we get interference. This is another one, it shows the same thing. You can see how big this opening is, or aperture. See, they are not diffracted light. Well, of course they go through, but here see, they diffracted and they go around. So that's why the closer these two slits are, the better diffraction and interference we get. First of all, I'd like to tell you about Thomas Young. He was a medical doctor in London. At the same time, he was physicist and also math. They call him polymath because he was so good. And then he chose this experiment, and you can see we have two slits over here, and the light goes through. Then because of diffraction, see this goes this way and the other one goes this way, and then how important this was, and then it saved, I mean, everything, and then it proved that light is electromagnetic, because if you remember last time we talked about Thomas Young, he was the one who discovered in a human's eye and retina we have cone cells, and they are stimulated with red and green blue light. Yeah. So then what you can see here, Thomas Young had two slits like this. Then he shone the light through these things, and he was expecting he is going to see two dots on this screen, but to his surprise, he didn't see those two dots. So those slits was a little bit far apart from each other. So what happened? He brought them closer and closer and closer, and finally he could see this diffraction. Not only he saw the diffraction, but also he saw the interference. You can see these labs, they overlap each other, and then what happened? You can see this, crisscross. But I have to explain scientifically what happened here. So every time we have a light going through this small slits, so we have like diffraction and interference, because that crest where the light is, crest is enhancing the other crest. So this crest from this one is enhancing the other one. Then you can see here we have bright light, and this is the same way. So crest is what? Crest is overlapping another crest, then we have like another light. But if the crest is interfering or overlapping the valley or the trough, so what happened? They cancel each other, and then we have like black lights. So everybody was expected that this was a good experiment, and it was in 1801, and so many scientists repeated, and then finally they come up with the same interference. And it just happened to that, in 1986, French physicists, they were thinking, what will happen if we do exactly the same experiment, but instead of light, we can have this small, device, and we can shoot one photon at a time. And to their surprise, well, of course, it doesn't show over here. They just shot one photon through the single slit. They had no idea the photon is going to go through this slit or this slit. They had no idea. So finally, they had some, light spots on this, because this was sensitive to light. And finally, when they shot many, like 100,000, photons single at a time, they realized it's forming, and now we can see these shaded areas and the light areas, shaded light. And this was exactly what happened to Mr. Thomas Young experiment. And you can see over here, we have exactly the same thing, which is called fringes. See, we have like dark fringes, light fringes, dark, light. So this was amazing experiment, and this proved that, that subatomic particles like electrons, photons can have both states. So in other words, they can be particle-like, or they can be, like a particle, or they can be like wave. Well, of course, I have some examples over here. See, this is Thomas Young experiment. You can see the fringes. And then what here you can see is photoelectric. When the light shows over here is, reflected like this. So in other words, we can get photoelectric effect. But I don't know how true it is. They said that, Thomas Young, inspiration came from water. And I think it's absolutely true. So we have here two, rocks or small marbles or pebbles. If you drop one marble in a real compound pound, so what happened? The light goes eccentric all the way to the shores and it stops. Well, what if you drop two rocks or two pebbles at the same time, simultaneously, close to each other? You can see we can have the diffraction of water, and we can also see the interference. And this was an amazing idea that Thomas Young was inspired, and then it just worked. And I have to mention something else. Light and sound have so many things in common, and diffraction and interference is one of them. And this is the more advanced. So this is the diffraction ring produced by electrons. Then you can see, but I don't know which lab they did this, but it shows the electron over here. But see this light and dark shades, so they are doing this interference. This poster is extremely important because it will explain what great physicists like Werner Heisenberg and then Niels Bohr, that why do we have both, wave and particle, properties. So this is the one, I had to get this part from the book, and which was amazing. This explanation is the most profound and the most precise explanation in physics. Who did this? Mr. Niels Bohr, and then if you remember, he was fantastic scientist. He discovered the atomic structure. He won the Nobel Prize. Then he was amazing scientist, and then him with Mr. Werner Heisenberg. Well, of course, you guys remember him. He was amazing scientist. Then he was the one who came up with the principle of uncertainty. What it was that, Mr. Heisenberg said it is impossible to find out where the electron is, the location. At the same time, it's impossible to find out what the momentum is. You can have one, not both of them. So this is the explanation for the Mr. Niels Bohr for the quantum mechanics, and then it says particles exist in a superposition of all possible states. So it means superposition. It means that we don't know it's wave, or we don't know if it's a particle. We have to do the experiment to find out which one it is. And then in fact, this was, he just called with Mr. Heisenberg complementary principle or Copenhagen interpretation, and everybody was, concerned that is light really electromagnetic, and then it was proven in Bell Lab with Clinton Davidson and Mr. Hermer, and then they had a nickel crystalline. So what happened? The light was diffracted, and they knew that it's an electron. And the breakthrough came when in 1860, Mr. James Clerk Maxwell discovered the electromagnetic wave, and then he calculated the speed, and then he realized it's a light. And in fact, we have to mention the most important scientist, which was so good in this case. His name was Louis de Broglie, the French scientist. And one day he was so mad, he said waves are particles, particles are waves. Then he proved this scientifically, and in 1929 he won the Nobel Prize. And in fact, he was in a Solvay conference. But most physics books, they explain that electrons are traveling like a wave, but absorb and emit like a particle. And in fact, this French scientist, if you remember, in 1986 they did this experiment, and then they realized it's exactly the same thing. And there was so much controversy. And this is a very important experiment. It's called quantum entanglement. I will just explain briefly what do we mean by that. You have one particle over here, one particle over here. If they are entangled somehow, if they communicate with each other, it stays for a long time. And it doesn't matter how much far apart they are, they will have this entanglement. But unfortunately, Albert Einstein had this bad, habit that, he would reject almost everything. And then finally he would say, yeah, it is right. And then he had two PhD students, Rosen and Podolsky. And what happened? All those three, they agreed that, entanglement is impossible. And in fact, it was in 2022, his name was physicist John Glauser. He brought everything back, and then he realized in his own lab he can do this. There was John Glauser, and then there was another scientist called Mr. Aspect. So they did this in their lab, and they proved that Albert Einstein was wrong. This can happen. This entanglement can happen, but unfortunately, that was like 160, 70 years after that. So this is what happened. So this is one of the most important, let me get this way. This is one of the most important conferences in the history of mankind, because you can see 29 the best scientists are in Belgium, in Brussels, and then out of these 29, 17 of them got Nobel Prize. The reason why this conference was held for quantum physics, because like I said a few minutes ago, it's very difficult for quantum physics to visualize because we are dealing with subatomic particles. Then you can see these great scientists like Max Planck, Marie Curie, Henrik Lorentz, Albert Einstein, Niels Bohr, Max Bohr, Louis de Broglie, Werner Heisenberg, Erwin Schrodinger, all these scientists, Compton, they were here. And it just happened that it was in October 1927, and they did a fantastic job. So this conference lasted for few days. Then they proved that light is electromagnetic and can have the both particle and wave wave. Well, of course, I forgot to mention something. Niels Bohr was an amazing physicist. And it just happened that, he had a debate with Albert Einstein for this entanglement, but I have no idea how long because it lasted a long time. And finally, Niels Bohr proved that, they can happen, but Rosen Podolsky and then the other guys, they said, no, it's impossible. But finally, they proved it. So you can see all the scientists were here in Brussels, so they changed our understanding for physics. And in fact, there were so many others. I had to choose another one. His name was Erwin Schrodinger. He was Austrian physicist. He also proved that the light is electromagnetic. Then he had an experiment. Let me get this down, then I can show you Erwin Schrodinger's experiment. It's very famous. It's called Erwin Schrodinger thought experiment with cat. Well, of course, I have to mention there was no cat, but it was a hypothetical thought experiment. So Erwin Schrodinger was Austrian physicist, and he got also Nobel Prize, and he was in the same 1927 Solvay conference. And I forgot to tell you, Solvay was a chemist in Belgium, and then there was a billionaire industrialist, so they helped them, and they would pay for all the expenses for the scientists, Albert Einstein and the other guys, so they would come over and then exchange views, because this was extraordinary thing for the science, because it was for the quantum physics. And imagine 100 years passed, and there's still some people don't believe that the light is electromagnetic, and they can have the both states. So Schrodinger said, if we have a cat, imaginary cat, in a box which is closed, we don't see it. So we put here atom of the radioactive, then there is a poison over here. If that radioactive decays somehow, we don't know, because this box is closed. If it decays, it will activate this hammer, so the hammer will break this poison jar, and then this cat is going to be dead. But they don't know. It was if that decays. So Erwin Schrodinger with this experiment showed that everything is possible when you are dealing with quantum physics. So if this is decayed, then this will be activated, this hammer will break this poison, and the poor cat is going to be dead. But of course, there was no cat involved, and most scientists said, yes, you proved everything. But if you open this box, and one more thing they said, they said, the cat is both dead and alive. It doesn't make sense. In my opinion, it can be dead or alive, but it depends on. But they said, yeah, it can be both. It cannot. It's just impossible. So what happened if you open the box, then you see the cat is still alive. So what happened is radioactive is not decayed, and this hammer was not activated, and the poison jar was not broken. So this was another thing that Mr. Schrodinger did, and then he proved the world that everything is possible. But overall, the bottom line was Mr. Niels Bohr emphasized, so was the Werner Heisenberg, that they are in a superposition. They can have both states. So it depends on how you set up your experiment. So thanks a lot for watching, and then if you like this video, you can subscribe. And like I said a few minutes ago, your encouragement, your feedback is extremely important for me. Thank you for watching.